While I'm rebooting, got the old fucking what was I going to say? It's going to be a long day. Maybe I should have a sandwich. Devaluing compliance. You just put it in drive and point and squirt. Oh. No, my gear set went for a gurgler. Hi, I'm Ed Winchester. No. Hi, welcome back to Clean Classics. Those of you who don't know, I'm Ollie. This Clean Classics is my company. In this episode, we are looking at things you might want to look at or know about if you're looking to get a classic car converted to electric. We'll also run through what we do and why we do it in all of our conversion builds. Keep watching to the end of the video. We've got a bonus tip that's really important to consider when it comes to getting your EV converted. So I'm going to run you through the top 5 things to look for when you're getting an EV converted classic car. Our top priority here at Clean Classics is weight. There's 2 elements of weight that you should be looking at. There's overall, and how does it compare to what the car was originally designed and built to carry, and secondly, and commonly overlooked, we believe, is the position of the weight and how it sits within the car, and just the consideration of how that might affect the vehicle dynamically once you're driving it. On the first point, overall weight, the way we look at it when we're designing a system is how much do all of the elements we're removing from the vehicle weigh. Off the top of my head, a 2.25 diesel engine that we took out of a vehicle recently was 260 kilos. So there's an amount of weight as a number that we can play with. There's also what are we taking out with the transmission, and also we're also keeping in the back of mind where did that come from in the position in the vehicle. And then you've got to look at the vehicle and think, okay, the batteries, we can match the weight and see what kind of range that's going to get. We could look at adding a little bit more batteries and adding a little bit of weight. Typically, we're kind of in that matching it a little bit more. Commonly, the way I look at it is you don't really want to be adding much more than a large passenger. That's for a Land Rover. If you're looking at a Mini, maybe you want to be a little bit less than that even. You know, it depends car per car. It's a good question to ask. If you're getting a Classic converted, what's happening with the weight? It's a no-brainer. It's amazing what you can do with these lithium-ion batteries these days. So matching the weight isn't an issue and you get decent range from it. With these old Landies, you could put a decent payload in the back, 100 kilos, it's not going to flinch. You know, that's perhaps one of your bigger friends in the passenger seat. So that we've considered is an acceptable increase. I probably wouldn't want to be pushing it too much further than that. But yeah, it's a really good thing to consider. The other aspect of the weight, and with my motorsports background, this is kind of where I get really interested and have really been trying to pay attention and do it right, certainly compared to some of the other approaches. So really, when it comes to position of weight, we're talking about the center of gravity of the whole vehicle assembly. You hear about 50-50 weight distribution, which is one element of the balance, but it's quite easy to put the weight really far forward, the weight really far rearward. You'll get 50-50 weight distribution, but the actual dynamics, you've then got a lot of heavy weights that you then need to turn. If they're in the center of the vehicle, you'll be able to turn that easier. Likewise, if they're lower, you're going to have less forces trying to push the vehicle over, you'll have less roll, and the vehicle dynamics are just going to be that much better. With a utility vehicle like a Land Rover, that we consider to be a suitable amount. We wouldn't want to go too much more than that. It's like having one of your bigger friends in the passenger seat. So the vehicle can easily take that. It could take a considerably larger payload than that. But you want to be having a sensible starting point. And these things are really strong. They're built just really robustly. But if you look at smaller vehicles like, I don't know, MG Midget or a Mini, the weights from the battery become all that more important. So it's a really important thing just to have in your mind. You've got the opportunity here to change it considerably, and the way we like to look at it is, if you're going to change it, either match what was there before or improve what was there. Now, of course, we're likely to be getting heavier, which doesn't quite match improving, but what we can do is look at where we put the weight with the batteries. We can get a little bit more creative with where that weight goes, because we're not working with the sort of conventional engine that goes in an engine bay. So that comes down to the sort of the center of gravity. The second thing to look for is voltage, power, torque. When it comes to voltage, it's fairly straightforward. There's a couple of options out there. There's some sort of lower voltage systems that are designed to be a bit easier, a bit more the hobbyist end. They're still good systems. You know, a lot of the professionals are fitting them. So they're kind of lower, and they're sort of 150 volt mark. And then there's a lot more systems coming out now, and it's where our system lies at, which is the sort of 400 volt OEM level of voltage. Voltage has impact on various things when it comes to the actual powertrain of the vehicle and the charging of the vehicle. Firstly, if you want to be making the most of DC charging network, typically you want to be up in the OEM level, 400 volts. The other thing with voltage is the lower the voltage is, the higher the current needs to be when you're trying to extract power from the batteries. If you've got higher current, you have thicker cables, you have more heat generated. Heat generated is effectively energy you're not using, so that impacts your efficiency. I've even heard stories actually of certainly when trying to drive bigger cars like Land Rovers, the lower voltage systems actually overheating and throttling back the power it will give you, like if you're on a longer run or trying to push it a bit harder in terms of driving. The voltage enables you to drop that current dramatically. If you think 400 versus 150 volts, you're going to be more than halving the amps you're drawing for the same power. And it's the amps that really generate a lot of the heat when it comes to passing the power through the system. But once you know what voltage your system's running, you'll also probably want to have a bit of a think about the power you're putting into it. And actually, really, the thing that's doing the work is the torque that you're getting from the motor. It's easy to think, oh, well, you know, I had 100 horsepower in there, I'll put 100 horsepower back in. The funny thing with electric motors is because of their torque from 0 RPM characteristics, actually an equivalent power doesn't reflect the increase in performance you're getting from that powertrain. Effectively, the power of an electric motor is at its fastest spinning point before the torque starts peeling off. So actually, you're only utilizing the peak power when you're going in a single speed, when you're going close to your maximum speed. So it comes down to the actual torque available, and depending on the transmission you've got fitted, there is generally abundant torque, and that's why electric cars are getting the reputation they are. They generally give you a more punchy acceleration through the board for a given power, because you're not waiting for the power band to lift to get the torque. You're just there straight away with the torque, and it's just the RPM increasing that actually gives you the power in the end. It's the old torque power conversation that everyone gets confused by, but it's broken down in a lot simpler way the way an electric motor works. So really, you're looking at the torque. If you're looking for good performance and worried about, what power am I getting, really you want to be looking at the torque numbers, torque to the wheels if you want to go through all the maths of the gearing and stuff. But if you're looking at a system that's got about the same amount of power that your previous car, the classic car, had, you'll be looking at a quite a sensible performance increase as it is. Anything a bit too much past that point, you can add a little bit, but anything a bit too much past that point, you really want to be considering what you're doing to the old vehicle components and whether they need uprating too. All the original driveline, axles, drive shafts, brakes even, you want to be looking at that. One of the good things about electric conversions on the brakes front is you'll also be adding regenerative braking. So you'll inherently be adding a level of braking upgrade by going EV. Helps improve the safety straight away by doing the conversion. Okay, the third thing that you want to be looking at, which ties on quite nicely for the power and torque thing, is transmission. Now actually, there's quite a lot to consider when it comes to powering your classic car with an electric motor. Do you keep the original gearbox and just run it like the original motor once did? Or do you take the lead from the OEM style of doing things and have a single speed, direct driven solution. Both work, but it's worth considering a variety of options when it comes to what you want for your conversion. The original gearbox option, is it suitable for the torque of the electric motor you're replacing the engine with? There are other little intricacies, like if you're changing gear with a clutch, if you don't implement the correct control strategy, if you dip the clutch, you'll then send the motor into regen. It'll pretty much stall out because there's no load coming from the drive wheels. And then when you dump the clutch again, you'll have a motor that has to catch up, and you'll basically spike the regen load every time you change gear. It's all overcomable with control strategy. But I think the main thing to consider with the gearbox is how reliable was the gearbox in the vehicle you have converted. These old Land Rovers, certainly the series ones, the gearboxes aren't renowned for being particularly strong. I actually owned one before setting Clean Classics up. I owned a Series 3 109, and within a couple of weeks of me taking delivery of it, the lay shaft bearing went and lost all drive apart from in fourth gear. I think if you're going to use the original gearbox, you want to make sure it's been reconditioned, it's in good health, and like I say, consider the gearbox you're using. We've opted for our conversion of the Land Rovers to remove all of the original transmission, and we actually use a stronger LT230 transfer box, which we remotely drive using a prop shaft to distribute the torque and power accordingly. We'll talk a little bit more about 𝗠𝗲 and the system we've put in a bit. If we then look at a direct drive as an option, as we've done here, the reason you might not choose to do that is it's more work that we, the converter, have to do. You know, if you take the engine out and you're just replacing a motor onto the end, you've just got to make an adapter to the belt housing and input shaft. Your powertrain work's done, whereas, you know, our whole powertrain is fairly custom. And so there's cost and time implications of a decision like that. We've taken that decision knowing that we're trying to gear up the level of manufacture for a specific vehicle, which keeps our costs fairly comparable to other conversion systems, whilst the quality and reliability of the system is increased by just adapting that area to be a little bit more suitable to the new powertrain. The next thing to consider is the battery you're having installed, the range you're looking for and what you can expect in terms of actual usability, and also the options you have in terms of charging your vehicle up. In terms of the battery, it really comes down to which vehicle you're getting converted. These old Land Rovers take a fair bit of energy to get from A to B. Our 40 kilowatt hour system generally gets you up to 100 miles. You know, that's a pretty usable 75 miles, but if you're hammering it down the motorway or you know, having a bit more fun in it, you could bring that down to below 50. Like it's just the way EVs are. Because they're more efficient, you notice more when you put your foot down, because the kind of general average low power driving gets you that much further. On the charging end of the scale, in terms of charging, you've got two main options, DC and AC. Your normal charging, when you plug in at home, it's typically around 7 kilowatts, can be up to 22 kilowatts, depending on the vehicle you've got. But the normal charging is AC charging, and what you find is there is a onboard vehicle charger that you plug into you can plug it into a 3-pin socket. Don't use an extension cable. Or you use the normal Type 2 charging socket on the wall. Most common of that is 7 kilowatts, which is normally a number of hours depending on the size of your battery pack. That's typically what you use at home. If you're trying to go further distance, things like the Tesla supercharger network and lots of other options. Typically with a DC charging system, there's a communication that happens between the charge station and the vehicle, and the vehicle effectively has a conversation with the charge station, understands it's the correct bit of kit, and opens the batteries to the DC station and it charges up. So it's much, much faster. So to compare, the 7, possibly up to 22 kilowatts AC, DC charging is somewhere between 50 and I think these days you can get 300 kilowatt charging. So it's much, much faster, obviously. The AC is fast charging, DC is rapid charging. And the 5th thing you want to be considering when getting a Classic converted to EV is all of the extra things that your engine was running probably, like power steering pump if you've got it, air conditioning if you've got it, but more commonly things like brake boosters which run off an engine vacuum. Heaters as well is a good example, because actually they typically use the heat from the discarded heat from the combustion engine. It's just a good idea to know what the plan is. If you're getting it converted as standard, we will always, if it had it, we'll fit it. We'll have the conversation with the customer, but that's our plan. Like, we don't take stuff out and go, well, you should have asked us to add that, it's extra. If it had it, we fit it. It's something worth not forgetting, because it's an easy thing to overlook. Things that you might want to consider are power steering, typically a pump run off a belt. You probably need to convert that to electric. 𝗏𝗏 here's got an electric vacuum pump that just pulls the vacuum that the engine once would have to the brake booster and just gives you a bit of extra force to the brake pedal. Air conditioning on some more modern vehicles, like the Range Rover Classic over there, may want air conditioning. Again, that would be taken from an engine-driven pulley to an electric motor-driven compressor. And the cabin heating in almost all conversions need doing, and just make sure that's what you're being offered in the cost breakdown you've got. It's a bit disappointing to once have had heating and then it go away. Even a lot of these old Classics, the heating's not brilliant, but it's nice to not lose that. In terms of the heating, typically what happens in an internal combustion vehicle, there's valves that will allow the actual coolant fluid that's cooling the engine, they'll allow it through a heat exchanger, which you then blow air over, and that's where the heat from your heating comes in most cars. Obviously, if you remove the hot engine, there's nowhere to then get that energy from. The conversions, we actually switch out and use just a PTC heater that we then use the original fan system to blow over and provide the heat. Funnily enough, everyone jokes about the sort of asthmatic heating system that old Land Rovers have. The fan remains the same. However, rather than it getting slightly warm by the time you've done a half-an-hour journey, you click the heater on and within a few moments you're nice and toasty warm. So actually, it's another thing that converting EV, sort of the thing you don't think about, but it actually improves that quite a lot too. The other thing in terms of ancillaries, accessories if you like, is what are you planning to do on the interior of the vehicle? Do you want to keep original dials? Do you want to have some snazzy new flash ones? Do you want lights flashing everywhere? Or the way we prefer to do it here at Clean Classics is not that many cues that you're in an EV conversion. We like to keep the original feel of the vehicle. We've got a small keypad that allows the drive, reverse, charging controls. Other than that, we reanimate all of the original dials to give you your battery capacity, speed. All of that is just as it once was, still nice and intuitive. But there's plenty of options. There's some really cool services out there where you can get some super fandango brand new gauges, and it depends on the build. If you're going more resto mod and going through the whole vehicle to try and bring it up to modern ways and modern feel, then that's probably more for you. If you're into the classic cars and a bit more like us, where we love them for being the classic cars they are, then you might want to keep the original dials and just be a bit more subtle about the whole thing. So now we've had a bit of a chat about what you might want to look for in a conversion. Let's have a little look at 𝗏𝗏, which is our first EV build here at Clean Classics. We can have a look at the system that we've put together for classic series Land Rovers. So, to start with, the battery in 𝗏𝗏 is split into 3 packs. 2 packs that sit where the old fuel tanks used to, underneath the seat box, central in the car and low down in the car. As we were talking about before, this really helps get that centre of gravity central and nice and low in the car, and it really those two battery boxes being there is really planting the car. It keeps that centre of gravity low down, and you can definitely feel the extra stability that it's giving you. The third battery box is at the front of the engine bay, just in front of the motor, but it's actually rearward of the front axle. Typically, you want to keep a lot of your heavy items within the axle. The further a heavy object is away from the point of rotation, the higher the force required to actually turn that object. So you can imagine if you've got a big weight out here and you've got to turn it around that point, it's going to take a lot more force than just rotating it on the actual pivot. So, and obviously, if you think about how a car moves, it does need to rotate as you're turning around a corner. So keeping weight like that more central is key. On top of the battery box at the top of the engine bay here is what we call our top box. That houses effectively the high voltage junctioning. It's got all of our ECUs in it. It's a nice, it obviously looks quite big, but we've designed it in that way that it's actually really serviceable. It's got all the space required to get in and build the EV portion inside. Also house our ECUs, the BMS, everything. It's integrated into the top of effectively the front battery box. And this is where we redistribute for the high voltage system for charging, for powering the motor and everything like that. We've also got here on the top box our 12-volt kill switch. These are quite common in a normal internal combustion engine, and it's doing the same job. It kills the 12 volts, but it'll kill the entire vehicle's 12 volts, but what that also means is it kills any supply to the contactors inside the battery boxes, which means it's another thing to grab. If for some reason something's gone wrong, you've been in a crash or whatever, it's something else that can just ensure you disable the system. We've got our own safety parameters in place that will disable the system automatically, but this is just another thing. It's the first thing we reach for when we actually want to go and do something on the system. We'll just go in there and turn the 12 volt off, then we know the batteries will be isolated. The second thing we got, which is hidden under here, is a service disconnect, which is, it actually mechanically pulls, makes a break in the high voltage circuit, and it does that at the halfway point in the high voltage circuit. It's in all EVs basically, but that splits it. So when you come to service it, you've got two packs of half the voltage, and bringing voltage down when it comes to working on stuff brings the sort of danger level down. So then we've got the motor and inverter stack, which sits right down at the back of the engine bay. Again, nice and low, nice as close into the transmission as we can get. The funny old thing about working with old cars is you basically have to work with the space you've got. Ideally, when you've got a four-wheel drive transmission like this, ours is single speed. Again, that's something we spoke about before, and we'll look at that in a second. So what we've opted for is a remote prop drive. So basically we've got the transfer box that is driven from the motor by a prop shaft, which just means we can separate them to actually get them to fit in the space that is available. So if we have a look back down in here, looking down between the front seats here, we can see the transfer box. This transfer box actually comes from, it's in Defenders, it's in earlier models of Discoveries, transfer box as well. It's a really, really well-known, robust, tested, you know, people are putting bonkers V8s through these. We know they're a good option of transfer box. The transfer box fundamentally gives the four-wheel drive system. So it takes the single rotational input and then outputs it front and rear. This has a differential, a center differential, which actually the original vehicle didn't have, so it would typically drive on the road in two-wheel drive, then you'd engage four-wheel drive. We've opted for this constant four-wheel drive because it enables us to push the regen up a bit. Another good bit of information about when adding regen to a vehicle is if it's a rear-wheel drive vehicle, you need to be very careful about how that integrates into the braking system, because if you over-regen the rear brakes effectively, you put the braking system out of balance, and the last thing you want is to put too much braking force on the rear axle. It would be like doing a handbrake turn basically. If you lock those rear axles up, you'll be turning around when you don't want to be turning around, and that could be dangerous. Anyway, back to the transfer box. So the transfer box offers you the differential, which is lockable. That's what we retain one of the 3 levers, the yellow lever, to operate the locking diff. So when you're in low traction surfaces, off-roading, the differentials allow the power to go out the easiest path. So when you're on low traction, or you might lift a wheel, the power will always try to spin that wheel up before it spins the other wheels up. Locking differentials ensure that you're spinning, so having a center differential will ensure you're permanently always spinning both the front and rear axles. So if you lift a front wheel, you'll still have grip on your rear wheels to push you forward. Likewise, as you're sort of moving, it'll change where you're gaining your grip. You can also have locking differentials on front and rear axles as well. Less common, more sort of off-road specific vehicles. These transfer boxes also give the option for high and low range. We've actually found, at the moment, we're removing the option for low range because the amount of torque we're getting from the motor it's plentiful in high range. Low range magnifies it by nearly 2 times. So we actually, when we first drove Purdy in low range, we were a little bit concerned for the old components. The low range was actually, we thought we were posing a risk to the reliability of the vehicle. And actually, if you look at the way low range works for an internal combustion engine, it's used for controllable torque. Quite a lot of the time, it's when your vehicle's in idle and you just kind of let it crawl. So it's magnifying quite a low torque provided by the engine at idle to a much higher torque that's really stable, and which allows you to descend, allows you to climb, all sorts. That doesn't really happen in the same way in an electric vehicle because you don't have an idle. So really, what you've got there is like a high acceleration mode, and whilst it's quite fun, it would take you up to sort of 30 miles an hour very quickly. It sort of doesn't have the same use case, and in this particular installation, we deemed it as actually something that could damage the vehicle and completely unnecessary. They're really fun just running in the high range ratio that we've selected. It's down to us, the sort of system designer and installer, to actually consider the ratio to the wheels between the motor spinning, the torque output, and basically the force that it puts to the tyres, to the ground. And then that also gives you your top theoretical speed and other things like that. It's been another driver in deciding to use the 𝗦C𝗰𝗶, as that has quite a few ratio options, one of which is it gets us very near to the sort of optimal Nissan Leaf ratio. That's where, by the way, all of our components have come from, is from a crash damaged Nissan Leaf. Typically they're sort of 2020 onwards. 40 kilowatt hour Leafs is what we're using, and yeah, we've generally got really high state of health on the batteries. We test through everything and make sure they're really in really good health. It's basically as close as we can get to brand new parts, but critically they're OEM quality. So the amount of R&D and testing and quality gone in, where you can just imagine, what Nissans are like. They're pretty renowned for being reliable vehicles. So as for charging, our system is typically running a 7 kilowatt AC, so the fast charging we were talking about earlier. At the moment, we're using a third-party charger by TC Electronics that we fit. We're actually, from now on, going to be using the charge system from the Nissan Leaf. We've had a bit of a changeover in our control system and our approach. In fact, they were the parts we were making in the last video. Is a tray for holding the charger. We haven't done it till now because they're big. It's a tricky thing to fit in, but we've had a bit of a sort of rethink and found a good space for it to sit in a space at the rear of the chassis. What that's going to be able to afford us is the DC charging that the Leaf originally had, whereas up to now we've not had that as an option. we're now going to be able to do, I think the Leaf goes up to something like 80 kilowatts. We'll probably be around the 50 kilowatt mark in terms of DC rapid charging. So that's really exciting. And we're just fitting the first test system to go and try that out. So that'll be really exciting to see. Next, I suppose, is actually what's it like to be sat in the cockpit of an EV conversion. First thing you might notice, we've got 2 pedals. No EV conversion needs a clutch because all electric motors can start from 0 RPM. And as I previously explained, this is a single speed system. So it effectively just drives as an automatic. You just put it in drive and point and squirt. In terms of dials and sort of user interface, if you like, we've got all the original dials. We've got temperature gauge indicating temperature of the battery. The systems will always kick in if it is overheating, then it will shut itself down well short of actually being a proper problem. But it's useful for the user to have that insight, especially if for some reason a trip out does occur. You'll have that right there on the original dial. Likewise, the fuel gauge is also reanimated to show the state of charge of the vehicle, and yeah, whilst it might not give you an exact number of miles left, it's perfectly adequate and very much in keeping with the feel of the old vehicle. You know you've got half the pack, you've got approximately this much left. Yeah, it just gives you an old school readout of the state of charge. We've also got the original status lights telling you what is going on with the car. And the best bet is just turn it on and show you what happens. So to start, like a normal old Land Rover, turn the key, and then the only addition we have in the cockpit is our little four key keypad here, which gives you your drive, your reverse, emergency stop, and charge selection buttons. So now the system is on, but it's not started. So if I want to drive, we'll just turn the key, foot on the brake, key there. You can hear a little click from the positive contactor, and then you can select. Again, we have to have the foot on the brake to actually select drive. So if I take it back out of drive, it won't actually select without my foot on the brake. There we go. I'll take it off again. So we've got lots of little safety details like that that are sort of bring it up to par with modern vehicles. You know, foot on the brake. Status lights that I was talking about before. The orange one here is your handbrake status light. You will not be able to drive the vehicle if the handbrake's on. It won't allow any torque to be output from the motor. You've also got diff lock engage light, so that you know it's bad for the transmission system to drive on good traction roads, like on good traction surfaces like the roads, with it engaged. So that just reminds you need to disengage the diff lock. This is also a sort of error status warning light. It'll flash if for some reason there is an error with the system. And then the red one is the charge indication. It'll flash at you when any charging or regen's going on. And also at about 25–30% charge, it comes on with a solid red glow, and that is letting you know you're running down on pack. We've designed that threshold at about the point you want to be regularly driving. So if you regularly charge the vehicle up to 100, all the way up to 100%, and drain it below, 20–30%, ideally higher, then you're going to start degrading the capacity over time. If you keep within those bounds, the battery's going to last a lot longer. That's another thing we have done. So we've got to put it into charge mode, you simply press the charge button. So that's now in 80% mode. You have to press it twice for 100% mode. So the normal charging daily use, you press it once, pop it on charge, and then it only goes to 80%. So you're keeping within those bounds. If you know you're going a bit further, you put it on 100%, and then you can extract that extra bit of range from it. Likewise, if you're driving every day and you see that red light come on solid, it's giving you that warning that you're slightly pushing the battery to be uncomfortable, and you might be limiting the longevity of the system. That red light coming on is also an indicator that you're starting to get low, and our system will then implement a gentle throttle cut as you're getting really low, and eventually it will cut the system. So it sort of gives you a nice gradual warning system that you need to either head home or pull over, depending on how out of batteries you are. Like and subscribe if you've enjoyed the content here, because it really makes a difference for us putting this content out there and building the channel. Really hope you've been enjoying what we've got. Also, if you've got any ideas of what you'd like to see here, please drop them in the comments.
This is the tray. I think you saw Ollie fabricating and trial fitting this last time round. So this has just come back from the powder coat guys that we use, Performance Powder Coating, and they've done their usual, it's like a low gloss, like almost a satin textured black finish that we have on our boxes, and yeah, looks really good. So the next stage for this is we're going to fit the Leaf PDM charger unit to this box, trial fit it into the vehicle. I've already made the looms up, so we're pretty much ready to fit this to the vehicle. I was going to get this, and then this is the point where that arrow comes up and it says RAF from the side. Bit of an update on what's going on down in the oily end of the operation. So yeah, well, we're going to talk through some drivetrain stuff. When a vehicle comes to us for conversion, one of the first things I do is fully inspect the vehicle and report back to the customer with what the vehicle general condition is like. We'll go through everything up to MOT standard. I also drop out the axle oils front and rear, make sure that the differentials aren't missing any teeth, there's no play in any of the pinion bearings or any of the other components. Inspect the brakes, remove the brake drums, replace hub seals if they need replacing, and make sure that the rest of the drivetrain is in tip-top condition. So this is a Defender LT230 transfer box. This is the type that we use in our conversions in the series Land Rovers. The series Land Rovers aren't fitted with these originally, so we source transfer boxes ourselves. We always fit a reconditioned unit, and if you're going to fit a transfer box, you don't want to just be fitting something second-hand. So we'll either sub this out and get it reconditioned by someone else, or we'll recondition them ourselves in-house. So this is what goes on inside the transfer box. So you've got your input gear, which sits in this part of the transfer box. You've got your intermediate shaft and gears, and then you've got your output shaft with your center differential and your high and low gear sets, and the selector collar in the middle for high and low. As you can see, you've got a lot of bearings in here, so one on each end of that shaft, one on each end of that shaft, one on each end of there. You've also got output bearings on the shafts either end, inside here, and you've got seals and stuff that all need replacing, gaskets all need replacing, so that you don't end up with any leaks. These LT230s are a bit prone to intermediate shaft wear, so when you're rebuilding them, you've got to make sure that the casings are okay and measure them, make sure they haven't ovaled themselves out, because they will leak. If whoever's doing your conversion is going to use your original gearbox, you do need to strip and inspect it. This gearbox came out of my '90, which was my daily driver until fairly recently, and at traffic, pulling away in traffic, the output splines on the LT77 completely let go. Don't know if you can see there, RAF, we're pretty smooth on the shaft there, and the input gear isn't a lot better. Generally, you replace these input gears when you're rebuilding the transfer box. They are a little bit prone to wear. The later ones are a bit upgraded as well. They're cross-drilled for better lubrication of the shaft, and we fit a remote transfer box kit from Shabs at Synchro Gearboxes. So he supplies those for us. So we fit a shaft and a flange, and then we prop drive from the motor straight into the LT230.
As promised, a bonus tip. Another one of the less obvious things to consider is DVLA and the compliance of the vehicle. In terms of actually getting one of these on the road, you need an MOT, and that people debate over it, but you do. There are some vagaries in the wording, but it's classed as a modified vehicle. Therefore, you need a yearly MOT. If there's any debate over it, I don't know why you don't just do it for £40–50 a year, and a ticket that lets you know it is in fact suitable for the road. I don't know why you wouldn't. So that's the absolute baseline. In terms of updating your V5 and other things like that, it's typically very straightforward. We keep the historic tax class, change the fuel type to historic, and we've had success in them being compliant for ULEZ and other things like that. So generally that's very straightforward. Sometimes the DVLA, and they have been by here and had a look, on certain builds it seems to be fairly random. Sometimes the DVLA will actually come and request to inspect your vehicle. That's when you want to know what's been done to your vehicle and how truly compliant it is. We're going through a bit of a weird time where the DVLA are a bit unsure of how to deal with EV conversions. So it can be a bit hit and miss, but at the moment they're being very hot on chassis modifications and other such things like that. Our system here at Clean Classics is fully bolt-in around an original Land Rover chassis. There's no cutting, no welding, no drilling required. It all bolts in, and therefore we know there's nothing that the DVLA are gonna throw us up on. So that's worth a conversation with your converter. Is what's the plan there? You know, where are you putting the batteries and how are you bolting it in? There's also, you know, that brings you back to the sort of batteries and structure. The weight of the batteries does need to be held by something designed to hold a lot of weight. So it needs to be looking at an engine mount or you know, something structural to the vehicle chassis. Again, is an element the DVLA might make a call on. If you've got a really heavy battery hanging off a flimsy bit of bodywork, they'd be within their rights to say that is not safe. It's all about making sure the vehicle is held together in a sensible way, that it's not going to be dangerous, and you know, you want to be putting safe cars out there into the world.
Thanks for watching. See you next week. Like and subscribe, motherfucker.